as part of the Global Prize for Innovation in Desalination competition aimed at finding and supporting innovative solutions. An advanced desalination technology is proposed to address the following challenges. Improve the environmental footprint of desalination processes. The proposed desalination technology aims to not only reduce the environmental impact of desalination processes but also mitigate the harm caused by the most widely used desalination technology. Reverse osmosis, which discharges toxic brine back into the sea. The multi-stage thermal desalination technology enables complete and environmentally friendly drying of produced saline solutions to sea salt, thus preventing harm to the flora and fauna of warm seas. Reduce energy consumption and operational costs. The desalination technology is based on the use of renewable heat and electrical energy sources, with the potential to additionally harness wind energy. Operational cost minimization is achieved by eliminating the use of expensive filter materials, membranes, and other costly consumables requiring special water treatment. The desalination plant is expected to operate in a fully automatic mode based on thermal parameters such as pressure, temperature, and liquid density. Limited areas of solar parabolic concentrators, several hundred square meters, allow for easy maintenance by a single person without complex technical systems. Introduce new technologies and innovative business models. The novelty of the technology lies in the use of innovative modular evaporators, drum film evaporators, providing an unlimited interwash cycle due to continuous mechanical cleaning of the heating surfaces to prevent salt deposits. The multi-stage evaporation process in identical modules reduces costs in mass production. The proposed business model is based on the mass creation of greenhouses and farms consuming about 20 tons of distilled water daily per desalination plant, producing dry sea salt with potential commercial value. The source of fresh water is proposed to be brines from desalination plants with a salinity of 60 to 80 grams per liter, with desalination plants ensuring unlimited free delivery of brines through pipelines to greenhouses and farms using this technology. Provide scalable and sustainable solutions to meet global water demands. The modular configuration of desalination plants allows for the creation of systems with any required optimal capacity from standard DFE elements patented for invention, and if necessary, increasing this capacity by adding the required modules. The sustainability of the proposed technology is based on the use of simple and well-studied physical processes of heat transfer, evaporation, and condensation, applied in drum film evaporators, as well as the stability of the hot climate and insulation in certain regions where the fresh water shortage is particularly acute. The project's development involves creating a pipeline system delivering toxic brine from desalination plants to numerous points where it will be processed into fresh water and dry salt, using only renewable energy sources without emitting harmful substances into the environment. The amount of fresh water produced, measured in tens of cubic meters per day, is sufficient for creating greenhouses and farms with drip irrigation, providing not only agricultural production but also addressing the issue of employment in some countries.
In 5 solar reflectors with an area of 350 m2, 371 kilograms of steam with a pressure of 330 kilopascals and 79 kilograms of salt concentrate with a salt content of 400 grams/kg are produced per hour. With multi-stage evaporation, this heating steam is enough to produce more than 22 tons of distillate and more than 450 kilograms of salt concentrate 400 grams/kg per hour. Multi-stage evaporation allows to produce much more steam than is expended, more than 2 tons per hour against the expended 370 kilograms. Thus, the modular thermal desalination unit consisting of 2 columns of 10 modules of drum film evaporators plays a key role in the proposed desalination technology. On average, 511 kilograms of salt concentrate from reflectors and evaporators are completely dried in an hour by hot air in a drying drum. During this time, more than 200 kilograms of dry salt and more than 300 kilograms of steam carried away by heated air are produced. Large salt particles carried away by the hot air flow are separated in a cyclone separator. In addition, the air is further purified from aerosols in a scrubber, passing through jets of water. Passing through the jets of water pumped from the pool, the moisture accumulated in the hot air condenses on the relatively cold jets and is not carried away into the atmosphere, but enters the pool. The task of the first block, consisting of 5 solar reflectors, is to produce heating steam for multi-stage evaporators. A simplified flow chart of the desalination plant is shown in the figure. The desalination plant considered as an example with a capacity of more than 20 tons of desalinated water per day consists of 3 main blocks. The proposed desalination technology is based on the use of innovative evaporators with continuous cleaning of heating surfaces and removal of sludge during operation. Another key advantage of this technology is the autonomy of the desalination plant, which can use only renewable solar and wind energy for energy supply. The most effective use of such a desalination plant is in combination with a greenhouse farm, since the heat accumulator in the form of a deep pool can be used for heating at night. An important economic factor in the development of technology is the commercial value of the resulting sea salt.
The desalination plant processes more than 30 tons of brine per day with a salt content of 70 grams per liter and produces more than 22 tons of fresh water and 2 tons of dry salt.